Now we've gotten to the last part of this topic, functions, and what you learn is creating your own function, and we'll see how important it is to create your own function. Before we dive into creating your own function, we need to know when you should write a function and why you should write a function. So when do you need to write your own function? When you find yourself copying and pasting a particular block of code and always adapting it to new data, new objects, then you need to create your own custom function. Also, when your code is a bit clunky and it's not readable, you've combined a lot of things, it's nice to break them down, and breaking your code down makes it readable, firstly to you, then next to other people that will be reviewing your code or that will be working alongside you. Now we'll create a sample data of cheek weights. We can do that using how. We create 10 observations with a mean of 245 grams, standard deviation of 120. And now these are the results that we have. Of course, we can set seed to ensure that this is reproducible. And I'll set my seed to 1 to 3. I'll call this cheek weight. There are times during our analysis when we like to standardize the data that we're having. And of course, to do that, the first thing to do with standardization is to get the mean of the data. In this case, this is cheek weight. We get the mean of cheek weight. Then after that, I'll call this cheek weight mean. Cheek weight mean. We also need to get the standard deviation for this cheek weight SD, like this. Now we can apply the formula for getting the Z-score, and that is each observation minus the mean, which is cheek weight mean here, divided by their standard deviation, and I'll call this Z-score. It looks like a pretty easy step, and that's correct. Once we check Z-score, we have the result. Now let's imagine we have 3 more data, each categorized for a particular purpose while we breed chicken. For example, we have layers, and we create a random number of their weight. Have 200 here, and we say 990 and 120. Then we have broilers. Also, we have 200. We have 1400. The standard deviation of 100. Of course, you can easily perform this operation again. What we need to do is we copy this and paste it here, since we need each standard deviation. But what we do now is we have to check each of these layers, and this will be layers. An easy way to go about this would be to highlight the parts that we want to edit. Then on clicking code here in the menu, you will see Ctrl+Shift+M, rename in scope. Once you click this, you can rename everything at once, but that's not what we want, as you can see that it affects this. So I will undo that now. I just want to show you that cool trick. So we have layers SD and layers here. Now Z-score, we say layers Z-score. Then now we include the data layers. We just keep doing it for each, just to ensure that we get the data right. Layers, okay. And mind you, we are going to do that for the next data that we have, the broilers data. So we can check layers Z-score here. One interesting thing about doing this is sometimes it's difficult to spot the error. Set seed. So we have layers here. So now we can check the mean, check the standard deviation. Yes, and we have this. So this is the Z-score. Now we'll do the same. Copy this again, or since I've copied this Z-score for cheek weight, I'll simply put this here. Now copying this would be better, seems easier to follow. So now you can also use Ctrl+F. Ctrl+F will bring the search bar, then you type in whatever you want to edit, then you include the character for what you want to replace. Then on clicking next, you see the next thing that you can edit. Hey, like this. Okay, now we need to replace, and replace. Works like magic. And running this, we'll get it absolutely right. And let's check broiler score now, and that's the result of broiler score. One thing that this does not expose you to is, at one point in time, you won't know when you leave this part as layers, because that's where you copied it from, or you won't know when you carried the data from layers here and you've been using it. Right here, you see that indeed this is broilers mean. And one interesting thing is, I won't tell you that you've made a mistake. it should just give you a result, and this is a result. But for people that are adept at statistics, they can notice something unusual in the results, like, okay, this is not what I'm expecting compared to this. And when you make changes as needed, you get the results you want. But there is no point going through this, especially if we have a lot of data, let's say more than 10. The likelihood of an error occurring increases as the number of times that we need to repeat this increases. What we need to do is we create a function, and to create a function, you type out the function keyword with open and close parentheses. Then you add the curly brackets in front. Then you press enter. Then in here you type the statement, the code expression, what you want to do. Now to make it clear, the argument that you want to enter will be entered within these parentheses. We'll just keep this as x. Then the formula or the statement, the code expression, what you want it to do, will be entered within the curly brackets. What we need to do is we need to find the average of our data first. So we say average of x, and that's mean of x. To ensure that missing data are removed, we can include na.rn equals true. But that's not all. We also want to check this SD, standard deviation of x. So we do this sdx na.remove equals true. Then now we can get the z value like that, or z score equal to, that's x minus the average of x, put this in brackets, divided by standard deviation of x. We include return. Now return here is a keyword, return z-score, and I will explain in a bit why we need to include return. If you run this, you just have this written out here. So if you see what we have here, you see that it's more or less the same step and process that we have down here, with the exception of the z-score. But we do need to include z-score, and I'll show you why in a bit. So we give this a name, z-score, like that. Now if we want to use this function, we can easily call it z-score. I'll put in the data that I want to check, which is what broilers in this case. So what this does is that it take x here is broilers. You can as well write x equal to broilers, because that's the argument. And if you run it, you have this result. If you compare it with broiler z-score, which we got here, you see that it's exactly the same thing. So why you can use unique here to just return a single one to see if it's the same. So why go through all this process, and rather than create a function, once you see that you are copying and pasting a code multiple times, or you are repeating an operation multiple times, it's better to create a function and use that function. So we have this now. I'll tell you why we include return here. If I'm to remove return right here and I press z-score, of course we are going to have the value of z-score, but the interesting thing is we won't see the value returned broilers, and we just have this, and that's because our answer is stored here in this variable, but this variable is not available to the environment, because this should actually be a variable that is holding a value, but now we do not have that. We only have the function name here. So to ensure that we always get the result that is stored here, we return, or you can use print z-score like this. So on running this, you have a result. Now there's another way to create functions. Of course, it will give us this, but it's a short form. For example, what we can do is we can highlight from this part from the part where we stopped the operation to the part that we started, which is this part. So what we can do here is we can press Ctrl-Alt-X, and pressing Ctrl-Alt-X brings up a pop-up. In that pop-up, we can write the function name. You can call it my z-score, for example. Now this is a function name, and you see what it does. It changes this to a function. We have the function added for us. Then all we need to do is replace broilers here with x. This will also be x. Then this will also be x. This will be x sd. This will be x, and you replace it all through as needed. And here we can use the keyword return, the function return, or leave it like this. The result is still the same. And here we have x, and also here we have x, and lastly x. And once you enter this, you can use it. My z-score, we had broilers also. broilers not found. Is it? Oh, object X not found. There's an error here, and that's this X. Yeah, I have to ensure it's consistent all through. And now we have this. Of course, you can compare it with the figure with the object which we created before, broilers X score, and see it's true. And we use unique to return the unique result. Okay, I'm spelling this wrong. Unique. Yeah, so we have true. Of course, you might forget the shortcut Control X. It's available right here in the menu. Once you click on code, you can look for extract function, which is this. So you have Alt Control X, this, then you have exactly the same thing. So in this lesson, we've been able to cover custom functions, why we need custom functions, and we've seen how important they can be. And furthermore, we saw how to create them and how to apply them.